A classic fractions question is to be able to compare two fractions with each other. We're going to look at 5 different levels of this type of problem so you can amaze your teacher with your skills.
Which fraction is larger, 2/3 or 3/7? This is a level 1 problem, and there's a couple of ways that we could solve it. The first way I want to look at is the idea of same denominators. Can we convert both these fractions into ones that have the same denominator, and then it will be easy to compare them and find out which one is larger. Now the denominator that I'm going to use is 21, and that's because it's the lowest common multiple between 3 and 7, and you can see that as 7 times 3 is 21. So what about 2/3? If we take 2/3, we need to multiply it by 7 to get our denominator, so we have to do the same to the numerator and multiply that by 7 as well, giving us 14 over 21. And you can see from the image that this is exactly the same size, it's equivalent to 2/3. Now let's try 3/7. In order to move to our denominator, we need to do 7 times 3. And as we need to do the same to the top as we do to the bottom, in order to make the fractions equivalent, we have to do 3 times 3 on the numerator side, which gives us 9 over 21. Now let's look at comparing these. We started off with 2/3 and 3/7. We've now converted that into 14 over 21 and 9 over 21. Now hopefully you can spot that the 14 is going to be bigger than the 9 because we have the same size parts. But just to prove it, here's the bars to show you. On the top we have 14 over 21, on the bottom we have 9 over 21. You can clearly see that the 14 parts are going to be bigger because all the parts are the same size. So to finish our question, we have 14 over 21 is greater than 9 over 21. And to put it back into the original fractions, 2/3 is greater than 3/7. But is this the only way to solve this problem? Maybe instead of using the idea of same denominators, we could look at the idea of same numerators. And lots of students find this a little bit challenging, but we're going to go through it now and hopefully it will make perfect sense. So, just like with my denominators, I'm going to try and find a common multiple. Well, pretty obviously, the lowest common multiple between 2 and 3 is going to be 6. So can we convert both fractions so they have numerators of 6? Let's start with 2/3. In order to get our numerator, we need to multiply it by 3. 2 times 3 is 6. And so we have to do the same for the denominator. So 2/3 is equivalent to 6/9. What about 3/7? Well, to get our numerator of 6, we have to double the 3. So we have to double the 7 as well. And we get 6 over 14. So our original question has been transformed into 6/9 compared to 6/14. They both have a numerator of 6. So how does that help us solve the problem? Well, we know that 1/9, 1 part out of 9, must be bigger than 1 part out of 14. So if they both have 6 parts, the 6/9 must be larger, and therefore the 2/3 is larger than 3/7. Let's have a look at this next problem, which I would consider to be a level 2 problem. And the reason for that is we've got two unknowns, and we've also been asked how many ways we can answer the question. We're not just trying to find one solution. So where would I start with this? Well, how about we make both the numerators 1? Well, that clearly doesn't work because 1 part out of 15 is definitely going to be smaller than 1 part out of 10. So maybe we could alter it slightly. How about 1 and 0? Well, this would definitely work. And if we kept the 0 over 10, we could just keep increasing the numerator forever and ever and get infinite number of answers. So perhaps we need a few conditions to kind of narrow down the number of possibilities. Why don't we say that the numbers in the boxes can only be positive integers, that's positive whole numbers, and that the fractions have to be the same or less than 1. They can't include improper fractions that would go above 1. So with these two rules in place, let's have a look at 2 as the numerator for 2 over 15. How about 2/15 is greater than 1/10? Can we make sure that's true? Well, if we multiply the 2/15 by 2, we get 4/30. If we multiply the 10th by 3, we get 3 over 30. Now they have the same denominator. We can clearly see that yes, 2/15 is bigger than 1/10. We could then keep changing the numerator of the 2/15 to 3/15, 4/15, and so on, all the way up to 14/15 in order to find some different solutions there. So we have those solutions, that sort of set. Are there any other solutions that we can think of? Well, how about if we now try a 2 for that 2 over 10? What would be on the other side to make it work with 2/10? How about 1/15? Well, we know that this wouldn't work because if we convert our fractions into 30ths again, we can clearly see that 2/10 is actually bigger than 1/15. So we can't have that. What about 2/15? Well, that would be 4/30ths. It still doesn't work. But what about 3/15? That would give us 6/30ths. They're actually equal, so we can't have that either. But 4/15, which converts into 8/30ths, definitely would work, as that's bigger than 6/30ths. Again, we could increase the numerator. We could have 5 and 2, 6 and 2, 7 and 2, all the way up to 14 and 2, and that would give us a second set of results. The key with this is to be systematic. So once you've looked at one set, you're just changing one thing to see how many different answers or types of answers you can find. We're not going to go through all of them now, but hopefully that's giving you enough of an insight into how you'd solve those problems. And we're really only using the idea of converting into the same denominator and maybe comparing numerators with the 1 over 15 and 1 over 10. Right, let's have a look at this problem, which I'd class as a level 3 problem. And if we have a look at this, we seem to have tricky denominators. We could times them together and find a lowest common multiple. In this case, the lowest common multiple is 184, which is a little bit annoying. And in terms of the numerator, the lowest common multiple of that is 154, so that's also annoying. But what you might notice is both of these are actually very, very close to 1. So we could use the idea of comparing the fractions to the number 1 in order to find out which is bigger. So if we take the 7 over 8, you can see that that's 1/8 less than a whole. So 1 take away an eighth would give you that 7/8. In a similar way, the 22 over 23 is 1 take away 1/23. So all we have to do is compare these differences and we can figure out which of the two fractions is larger. If I look at my number line, from 1, if I take away a 23rd, I get to 22 over 23. If I take away an eighth, I get to 7/8. And we know that 1/8 must be larger than 1/23. Therefore, 7/8 is the smaller of the two fractions. It's further below, further away from 1. So, to complete the question, 7/8 is less than 22/23. If you want to know more about these methods, I recommend checking out this video, but let's carry on for now and see what other types of questions we can look at. So this question I would consider to be a level 4 question. So let's have a look at it now. There's 2 pieces of ribbon have been cut. Here are the pieces that are left. So they're not the original pieces, they're the bits that are left. Which piece was longer to begin with? Now, the difference between this question and the previous question is in the previous questions we're comparing two fractions that will have the same whole. Here, the 2 pieces started off as different lengths. So 5/6 of the blue ribbon is equal to 3/4 of the orange ribbon. And that's a difference from the questions before, and it's something we have to think about. So, how can we find what the original lengths were? Well, if the fraction of the blue ribbon left is 5/6, we can divide that up into 5 parts and each of those will be worth a sixth. Now all we need to do is add on an extra one, so we get 6/6, and this must be the approximate length of the original bit of blue ribbon. Can we do the same with the orange ribbon? Well, the orange ribbon is 3/4 of it is left, so let's find out what a quarter is. If we split it into 3 equal parts, each of those parts must have been a quarter, and adding on one more quarter will get us back to the original piece. Now we know that if we take the same size bar to begin with and split it up like this, the quarter must be bigger than the sixth that we're adding on the end. Therefore, the orange ribbon must have been the larger one to begin with. Let's try another version of this question to see if we can cement that understanding a bit further. This is question 2. Only a fraction of each strip of paper is known. Which strip is longer? So you can see that this blue sort of sheet of paper is covering up these strips. We can see that 1/8 of one strip is exactly equal to 1/7 of the other. How can we get back to the original strips? Well, if the turquoise bar is working in eighths, we know that we're going to need 8 of them to get back to the original strip. Similarly, if we've got sevenths, we know we only need 7 of those blocks to get back to the original orange bar, meaning that the top bar must have been the longest. Let's try a slightly more challenging version of the same problem. Question 3, only a fraction of each strip of paper is shown. Which strip is longer, the red or the green? So 2/7 of the red strip is equal to 3/9 of the green strip. The question we need to ask ourselves is how many of those red blocks do we need to get back to the original size of the red strip? Well, we need 2/7, 2/7, 2/7 gives us 6/7, and 1/2 of that block will give us the last seventh. And if we compare that to the green block, because it's in 3/9, we only need 3 of them to make the original the whole strip. Therefore, the red strip must be the longest. The last type of problem we have to look at are the level 5 problems, and I think these are even more challenging than the ones we've done before. So let's have a look at this. Find the midpoint between 1/5 and 1/3. So again, we're comparing the fractions, but we don't just want to know which one's bigger, we want to find the midpoint. So this ups the level of difficulty. Let's have a look at both the fractions and the number line. We can see that a fifth is clearly smaller than a third, but we have to find the middle of that line between them. So what I might do is start by converting both of them to the same denominator. And 1/5 we can convert into 15ths, which is 3/15ths, and a third is going to be 5/15ths. So the difference between the two fractions is 2/15ths. As we want the midpoint, if we split this difference in half, we can see that 3/15ths plus 1/15th will give us 14/15ths as our midpoint. Let's up the ante a bit with a harder version of the same problem. Find the midpoint between 1/11th and 1/5. Again, on our number line, we know that 1/11th must be smaller than 1/5, but what's the midpoint? Well, first we need to find the difference between the two fractions like we did before. Can we use a common denominator? Well, the easiest one would probably be 55. So if we convert 1/11 into 55ths, then that would be 5/55. And if we do the same for the 1/5, it's going to turn into 11/55. That gives us a difference of 6/55. Now we want to find the midpoint, so we split that difference in half, which is going to be 3 and 3. And we can do 5/55, add the 3, gives us 8/55 as the difference. Is there another way? Well, what we can do is find the mean. And the mean is going to be exactly in the midpoint between those two numbers. To do that, we want to add them together. So we still need to convert them. And then we want to divide that total by 2 because there's two numbers. So half of 16/55 is just going to be 8/55. So that must be our midpoint. So there's two different versions there. So we're moving on to the final problem we're going to look at in this video, and it's find the midpoint between -2/3 and 4/5. And this one looks a little bit tough. So how are we going to do it? Let's look at our number line again, but this time we're going to have 0 in there because we've got one fraction below 0, one fraction above, -2/3 and 4/5 on there. Now we want to find the difference. So first of all, we need to just label that -2/3 is 2/3 away from 0 or below 0. And 4/5 is 4/5 above 0. So what's the total difference there? Well, if we add those together by using same denominators, we get 22/15. So that's the difference between -2/3 and 4/5. Can we now split that difference in two? Well, half of 22/15 is 11/15. So the midpoint is going to fall 11/15 above -2/3 or 11/15 below 4/5. Let's convert that into 15ths. Add on the 11/15. If we add on 10/15, we get back to 0. So we need one more 15th. So the midpoint is going to be 1/15.
We've come to the end of our comparing fractions video, and we've looked at 5 different levels of these type of problems. Hopefully you've gained some insights there, but if you want more, then check out the ordering fractions video that we have and fractions of a number.